Hey, what's up guys? We're going to do Unit 5, Section 4, which is the other trig functions. And I'm basically just going to tell you what it is you need to know. It's in this section right here. It's really simple. You need to know, let me write sine, cosine, and tangent. Alright, sometimes we use theta, but here's what you need to know. Whatever sine is, that is related to cosecant. And cosecant is just 1 over whatever sine of x was. Same thing for cosine. The related function to cosine is secant. And that's just 1 over whatever cosine of x is. Tangent is cotangent, and that's the same as 1 over whatever the tangent of x is. So let's do some problems. Find the exact value of whatever this is. Okay, so here's what we're going to do. Let's figure out what value that is in degrees. So let's convert it to degrees. 9 pi over 4 times 180 over pi. Pi's cancel. 2 into 4 is 2. 2 into 180 is 90. 2 into 2 is 1. 2 into 90 is 45. So we end up with 9 times 45. 9 times 45, 405. So this is the same thing as saying 405 degrees. So let's kind of figure out where 405 degrees lies on this unit circle. Well, I shouldn't say unit circle, but on the coordinate plane. So if we subtract a full revolution from it, so we're going to subtract 360. So that is 405, is 405, right? Yep. Minus 360. We end up at 45. So 405 degrees, it like goes around a full 360 and then comes back at 45 degrees. I'm just going to erase that little piece right there. Alright, so this is like saying the secant of 45 degrees. Now, you need to use your reference triangle. And the reference triangle for this one is, I'm trying to make it look, no, that looks like a 30, 60, 90. Whatever, it's just a picture. 45, 45, 90. And across from each 45 degree angle, we have 1. And then the larger side, which is the hypotenuse, we have square root of 2. So let's figure out what sine of 45 is. Well, actually, I should say 9 pi over 4 because it's the same thing, right? So 45 sine is opposite over hypotenuse. Let's do the same thing for cosine. I'm just going to call it x. Cosine is adjacent over hypotenuse. They're both the same. And now that we know what's, well, let's do tangent as well. Let me write tangent on the side here. Tangent of theta of 45 is 1 over 1, which is just 1. Right, opposite over adjacent. And I was focusing on this angle, this 45 degree angle here. So to me, this is my opposite, this is my adjacent, that's my hypotenuse. Okay. So now that we know these, I can tell you what cotangent is. Oh, by the way, I totally forgot to mention, this is in CAST. I like to think of cast. This is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. All of them are positive in quadrant 1, so we don't have to worry about signs. Cotangent of x is just what's, if you take 1, this is 1 over 1. If you think about cotangent as being 1 over whatever tangent of x is, it's just 1. I guess putting it over 1 here didn't really help me. Alright, but you still get 1. What about this? This is cosecant of x is equal to 1 over whatever sine of that is. So it's 1 over 1 over square root of 2. And that's the same as saying 1 divided by 1 over square root of 2, which is the same as saying 1, I'm going to write my 1 like that, times the reciprocal. And what do you get? You just get square root of 2. Alright, so that's cosecant of x. Let's put that in right there. Well, you can see that that's the answer. Cotangent, you can see that that's the answer as well. Tangent, you can see that that's the answer as well. And the last one is secant. So I'm going to think of secant of theta is equal to 1 over cosine of theta. And that's just 1 over square root of 2. And it's literally the same work that we did for this. It's the same work. So we're going to end up with square root of 2. And you can see that that's exactly what it is. Alright. Same thing here. Let's convert this to degrees. So that's 13 pi over 6. This is in radians. Alright, so the way I like to think about it is I just put radians there. And the conversion is pi radians is equal to 180 degrees. So if I put 1 over the other, it's 1. But I know since I have radians up here, I want it to cancel out with radians down here. So I'm going to make sure I have my radians here. So pi radians is the same thing as 180 degrees. Alright, this whole fraction is the number 1. I'm just multiplying by 1. I don't change its value. Okay, so radians and radians cancel. The pi and the pi cancel. 6 into 6 is 1. 6 into 18 is 3. So that's 30. So 13 times 30 is 390. So this is 390 degrees. Now minus a full circular turn, full revolution there, and you actually get 30 degrees. And guess what? That lands in the positive side, right? Like this was 360, then you have to go extra 30, just like that. So it lands on the quadrant where they're all positive. So thank goodness again, they're all going to be positive. All right. If it landed over here, let's just say it landed over there somehow, right? Then only sine would be positive. But also, what's the other function that goes along with sine? Cosecant. That would also be positive there too. All right, so and everything else would be negative. So just keep that in mind. Okay, so let's see. So we need a 30, 60, 90 triangle. Let's make that one 30. This is 60. That's my 90. So across the shortest side is 1. Across the longest side is 2. And then square root of 3 is 1 point something. That's the in-between side. Okay, and you know the side across the 30 is the shortest. The side across the 90 is the longest. Alright, so let's do our sine, cosine, and tangent. And then we'll just see what the others are. So sine with respect to 30, so we're looking at this angle over here, is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And if you have no clue where I'm coming up with that, that is just so Katoa. Right, I'll just write it in that corner for you. So let's write cosecant. So it's 1 over a half, and that is actually just 2. Right, like how many times could a half go into 1? Twice. So this one is secant. So that's just 1 over cosine of x, which is square root of 3 over 2. And I guess I'll just do this one out for you so you can see it. That's 1 over 1 divided by square root of 3 over 2, which is the same as 1 over 1 times the reciprocal, so 2 over square root of 3. So you end up with 2 over radical 3. Okay, I just paused it for a second because it's like, wait a minute, why don't the answers match up? But they do, they're the same. So I'm just gonna write 2 over radical 3. Now, I've never found a good reason for this, but usually teachers love to see the denominator rational. So how do I rationalize this? I just multiply by 1. Right, everything is multiplying by 1. You always keep it the same. Square root of 3 times square root of 3 is just 3. That's like the square root of 3 squared. And the top is just 2 square root of 3. Okay, and you can see that the cosecant of x is 2, which is exactly what's there. Tangent, again, they rationalized it, but it's the same answer. 1 over square root of 3. And it's the same exact answer. And then cotangent of x, I should really put x since I've been using x. So that's 1 over tangent of x, which is 1 over square root of 3. And you want to guess what happens? Well, that's 1 times square root of 3 over 1. So you just get square root of 3. So theta is in quadrant 2. And they're saying sine of that angle is 3 over 7. So here's how you want to think about it. Remember, sine of an angle is equal to opposite over hypotenuse, right? Opposite over hypotenuse. So let's kind of put that into the picture. So opposite of that angle is 3, and the hypotenuse is 7. So let's figure out what that is. We can use the Pythagorean theorem. A squared plus b squared equals c squared. So c is the hypotenuse at 7. A and b are the legs. It doesn't matter which one you put where. We're trying to find one of them. So that's 9 plus b squared is equal to 49. Minus 9 on both sides. We get b squared is equal to 40. Take the square root on both sides, we get, well, square root of 40 is equal to square root of 4 times square root of 10. And the square root of 4 is just 2, so we can write that as 2 radical 10. So this side is actually 2 radical 10. Now using that, we could find all of the other sides. And let's do that. So cosine of theta is adjacent over hypotenuse. So that's 2 square root of 10 over 7. And let's type that in and see if we get that. Oh, and I totally missed this. C-A-S-T. We were talking about sine, so it's positive in this quadrant, but cosine is negative in this quadrant, so it should be a negative number. So let's see if we get this nasty looking decimal. -2 square root of 10 divided by 7. Yep, and you get exactly that. So let's do that for the other one, tangent. So tangent is equal to, I'm going to write SOHCAHTOA right here. SOHCAHTOA. So tangent is opposite, which is 3, over adjacent, which is 2 radical 10. And it's negative in that quadrant. Okay, secant. Now, which one does sine go with? Does sine go with secant or cosecant? It goes with cosecant. I always used to make that mistake. So this is cosecant is just 1 over whatever sine of theta is, so that's 3 over 7. So that really just works out to 7 over 3. Right, let's just test that out. And you can see that we get that 2.333 recurring. So cosine goes with secant, so that's just 1 over, well, all of that stuff. Can I just flip it right here and just say negative 7 over 2 radical 10? Let's type that in and see. Negative 7 divided by open parentheses 2 radical 10. Oops. Close parentheses right there, and you can see we get exactly that number. Cotangent, you just do the same thing too, so it'll be negative 2 radical 10 over 3. And just to prove that that's right, 2 radical 10 divided by 3, and there should be a negative sign in front of it. Yep, there we go, all correct. Without using a calculator, find the exact value of that thing. It looks like the equation of a circle, right? I'm not going to get into all of that, but let's just solve it the way we know how. Notice that they're using the angle 30. So let's draw ourselves a 30, 60, 90 right triangle. The side across on the shorter side is 1. The side across on the longer side, which is the hypotenuse, is 2. And then the middle side is square root of 3. So let's set up sine and cosine. In this case, we're focusing on this angle. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So that would mean cosecant would be 2 and secant would be 2 over radical 3. And let's just, like, we have all the information now. So this just means 12 times cosine of 30 is this. So this is just radical 3 over 2 squared, because they are squaring it, plus 24 times cosecant is 2. And don't forget, that's also being squared. Now let's just work that out. So this is 24 times 4. And this is 12 times 9 over 4. All I did was square the top and the bottom. Sorry, square root of 3, square is 3. And let's just continue solving it. 4 and 4 is 1, 4 into 12 is 3. 3 times 3 is 9. 24 times 4, 4 4s is 16, carry the 1. 4 2 is 8 plus 1 is 9. 96 plus 9 is 105. Compute the exact value of each of the following, and they tell you to type it in. Alright, sine of 210 degrees. So here's what we need to do. We need to figure out what the reference angle for that is. So this is 90, that's 180. Now I know if I went all the way here, that'll be 270, but we didn't. So we're gonna stop somewhere here. And so all of this is 210. Right, that's 210 degrees. But what is the reference angle? Well, that we have to subtract the 180 away from the 210 to see how much extra went over. So 210 minus 180, 30. So our reference angle is 30. So we're going to think about a 30, 60, 90. In fact, I'm just going to, should I draw it right here? Yeah, whatever. So 30, 60, and this is a right angle of 90. Smaller side across from the 30 is 1, across from the right angle is 2, and across from the 60 is square root of 3. Yeah, let me just erase this. I think that'll help me a lot more. Good, that's a lot better. I'm gonna put my radical 3 right there. Okay, so let's do some stuff. Oh, by the way, cast, C-A-S-T. All right, don't forget, this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. And we know that sine is going to be negative in this quadrant because we are working in this quadrant. So we know sine is going to be negative right away. Sine is opposite over hypotenuse, so that's 1 over 2. Cosine is also negative in this quadrant, and cosine is adjacent over hypotenuse, so square root of 3 over 2. Tangent is positive in this quadrant. Tangent is adjacent over, nope, it is not adjacent. See, this is why it's good to write so, ka, toa is opposite over adjacent. Opposite is 1, and adjacent is radical 3. Now they like to rationalize it, so if you want, you could just multiply the top and bottom by radical 3 and you'll get this answer. Compute the exact value. Same thing. Okay, but this time they gave you radians. Let's convert this to degrees. So negative 5 pi times 180 over pi. Pi's cancel and you remain with, what is negative 5 times 180? Negative 900. Okay, let's graph that on the coordinate plane. Now let's minus 360 from that. In this case I have to add it to remove it, so that's 1 revolution. Let's add another 360. Ooh, and it lands exactly at 180. So here's what that means. The negative means that it's going in this direction, right? So that's negative 360. And what do we get? We got negative 540. So at that point it's negative 540. I minus another 360. So I went around again. And I ended up with an extra 180. So that means that it went this way and it landed right there, forming 180 degrees. Okay, so that's interesting. So there is no reference angle because it's on the line itself. So here's what I like to do. Think about the unit circle, right? So think about the radius of the circle as being 1. What point is this? That was a bad set of parentheses. What point is this? That's a point negative 1, 0. Remember, this is your cosine of theta. This is your sine of theta. So let's see. Sine of that angle is just 0. Cosine of that angle is just negative 1. Now tangent, what would tangent be? Tangent is just sine of theta over cosine of theta. So that is literally just 0 over negative 1, but it's still 0. Let's do this one. Same thing here. Now we could actually work in radians, but I'm going to convert it to degrees since that's how we've been doing it. So pi over 6 radians times 180 over pi. They cancel. 6 and 6 is 1. 6 into that is 30. Reference angle of 30. We've done this a million times. That's 30, 60, 90. Across from 30 is the shortest side, across from the right angle is the longest side, and across from 60 is the middle length side. Sine is opposite over, let me just write it, I'm getting tired. SOHCAHTOA, opposite over hypotenuse. Oh, and I should mention, we should have looked at this. 30 degrees, it lands right there. Right, if it was more than 90, we would have to find a reference angle. Thankfully, it was just 30, so we could kind of work with it. And they're all positive here, so we don't have to worry about sines. Sine of 30 is opposite, which is 1, over hypotenuse, which is 2. And cosine of theta is adjacent, so that's square root of 3. Remember, we're focusing on this angle, the 30-degree angle. So adjacent is just the one next to it. That's not the hypotenuse. And adjacent over hypotenuse is that. Same exact answer. Last but not least, find the exact value of the given expression and simplify. If the you see here it tells you if the denominators are rational, rationalize it. Why? I don't know. Okay, so let's see. They gave you a bunch of different degrees that we have to convert. Let's do that. Let's do the 315 degrees first. Oh, actually, no, we don't have to convert it. Thank goodness. But we do have to find the reference angle. So let's see. 90, 180, 270. So it's more than 270. So it's going to be somewhere here, right? This will be a reference angle. Now, all of that turning from here all the way that way is 315. How much extra would we need for that reference angle? So let's minus that from 360. 360 minus 315 is 45. So that reference angle is 45. Remember, the reference angle is always made with the x-axis. So that's like saying secant of 45. And remember, cast, C-A-S-T. Well, is it going to be positive or negative there? This is cosine. But what also goes with cosine is secant. Remember, the thing that goes with sine is cosecant. So this will be positive, so we don't have to worry about that. In fact, let's just do that little piece right now. If we have a 45, 45, 90 right triangle, side across from, I'm focusing on this angle, side across from that is 1. Side across from that is 1, and then the side across from the right angle is the square root of 2. Right, that's a 1, 1 square root of 2 triangle. So let's do cosine. Cosine is adjacent, so that's 1 over hypotenuse, which is square root of 2. So secant is just going to be square root of 2 over 1, which is just square root of 2. So this little piece here, well, this little piece here I should say, actually turns out to be square root of 2. Minus, so let's work out this piece here. Well, minus 2 times, we're going to work out what tangent of 210 degrees is. Ooh, alright, I'm going to do it right here. Let's see what 210 is. That's 90, that's 180. I know if I went all the way here, that would be 270, but we didn't get that far, so we got to 210. So all of that turning is 210 degrees. But after 180, how much extra did we have to go? Well, 210 minus 180, that's a 30. So this is another 30 degree triangle. So let's see, let's make that 30, 60, 90 right triangle. 30, 60, 90. Shortest side. Well, this pic, I should have switched to 30 and 60 because the picture doesn't really show it. But across on the 30 is 1. Across on the 60 is square root of 3, and then the longest side is 2. So we need tangent. And oh, since it landed here, and notice that that was positive, right? C-A-S-T. So tangent will be positive there, which is great. Tangent is So we're focusing on this angle, the 30-degree angle, opposite over opposite over adjacent, 1 over square root of 3. I'm just going to write SOHCAHTOA here. You know, you're never too old to write SOHCAHTOA. Write it. And I wrote over the problem here. Ooh, that's special. So there's no plus or minus here. It seems like you're just multiplying times tangent of negative 120. All right, so let's do our other one. Draw my thing again. Negative means I'm going backwards, right? So this is negative 90. I didn't get all the way to negative 180. So this is my negative 120-degree angle. I need to know how much extra to get to 180, negative 180, and that's 60. Notice that tangent, it's also in the quadrant where tangent is positive, so don't have to worry about that. But I am focusing on this 60-degree angle. We're going to use the same triangle. Focusing on the 60-degree angle. And remember, tangent is opposite over adjacent. Opposite in this case is square root of 3, and adjacent is 1. Alright, cool. Let's just work this out and see what we get. So I'm going to multiply these two things there. You just multiply them across, and you end up getting square root of 3 over square root of 3, right? Which happens to just be, because they cancel each other out, 1. So this is really just 2 times 1, which is 2. So square root of 2 minus 2. And you can leave your answer just like that, and that's exactly how they gave it. Alright guys, I will catch you on the next one. Peace.